Hello friends, let's continue with our series. In the lecture number 8, we will be learning about calculus basics, which are derivatives and gradients. Alright, let's begin. Derivatives. The derivatives define a measuring change. A derivative shows how much a function changes with the respect to its input. Right? As we have already studied, a derivative basically shows the difference or the ratio of difference of a function with respect to its input. We can think of it as the slope of a curve at any point, right? In machine learning, it tells us how much error or loss changes when we tweak model parameters, right? So basically it means that it tells us or it defines us how much the difference in the error or the loss in our data or the loss in our accuracy was existing when we tweaked our model parameters, right? When we changed our model parameters, when we edited them in order to give them a better training and hopefully get a better result. For example, if loss decreases as weight decreases, derivative tells us which direction to go, right? So for example, if a loss is decreasing, if a data loss or data accuracy is decreasing at the weight changes, so in this case a derivative will tell us which direction to we go. Should we keep on proceeding, should we go back, as we want the loss to be kept as minimal as possible, right? Next we have gradients, multi-dimensional derivatives. In this we know that a gradient is a vector of partial derivatives for functions with multiple inputs, right? A gradient is simply a vector of the partial derivatives for functions that has multiple inputs, right? It tells us the steepest direction to move in to reduce error, right? It allows us to observe the steepest direction, and this direction once moved will be able to reduce errors in ML. It is used to update weights in algorithms like gradient descent, right? So in machine learning it is basically used to update weights in our algorithms. It also helps in optimizing models which have many parameters, which is common in deep learning. It basically has the properties which assisting optimization of our models that have a lot of parameters. This is very common in deep learning projects. And finally, role of machine learning training. Machine learning models learn by minimizing a loss function. Gradients are used to compute how each parameter affects that loss. Combined with an optimizer, example SGD, gradients help find the best model parameters. This process powers backpropagation in neural networks. Alright. So basically a machine learning model learns by minimizing a loss function. The more it minimizes the loss function by going back and retraining the model, trying to achieve a better and improved accuracy, the better our model learns. And in this, the gradients are used to compute how each parameter will be affecting towards a specific loss. We will be evaluating each of the parameters, and the parameter whose change brought a loss or brought an additional loss, that will be dealt with by minimizing the loss function of this parameter, or the loss function that came when using this parameter. Then we will be combining it with an optimizer like SGD. The gradients help find the best model parameters, right? Using the gradients, you will learn more about gradients later in our course. Using the gradients, we will be assisted in finding the best model parameters, the parameters which are best used to contribute towards the training of our model. And this process powers backpropagation in neural networks. What is backpropagation? It is simply the process where we go back in stages and fix any kinds of loss functions that might have been introduced in our model. We propagate back, we check for the parameter that caused an issue with our model, and we fix it. That is called as backpropagation. That's it for this video. I hope you were able to understand, and thank you for watching.